Salam everyone, welcome to Physics with Noshir Alam, and today we're discussing electric fields. Now, electric field की definition क्या है? What is an electric field? It is basically a region around a charge. Now the charge could be positive or negative. The region around a charge in which its force can be experienced. That is the basic definition of an electric field. Now, as you study in no levels, there are two types of charges. You have positive charges and you have negative charges. For positive charges, the electric field lines are always outward pointing. Remember that you have to draw 8 field lines to cover all directions. The lines are straight, must be drawn with the ruler. And for a negative charge, the lines are always inward pointing. These lines represent the direction of the force. And let me explain that to you. So, if I put a plus charge over here, आपका ख्याल है कहाँ जाएगा? Opposites attract, right? So the plus charge would drift in this direction, in the direction of the line. So this line is also known as the line of force. It gives the direction in which the force will act. Likewise, if you put a plus charge over here, ये कहाँ जाएगा? Repulsion होगी ना, इस तरफ जाएगा. So same concept. This is the line of force, which means it shows the direction in which the force will act on a positive charge. Now the question remains, how much will the force be? And that force is represented by capital F, right? And it also brings us to the concept of electric field strength. Now, electric field strength is defined as the force acting per unit positive charge. The force acting per unit positive charge. So electric field strength is defined as force per unit charge. Now please remember, the confusion lies per unit positive charge. अगर आप इस क्वेश्चन पे अप्लाई करो तो ये दोनों पॉजिटिव हैं. कौन सा चार्ज ये वाला है? Remember, this is the charge which is moving, the smaller charge, or the test charge. So this is the charge, and usually you call it the test charge, जिसके ऊपर फोर्स लग रही है. जिसके ऊपर फोर्स लग रही है उसको, जो मूव कर रहा है वो वाला. The smaller one, or the test one, or the one which is moving, that is the charge which you will use in this equation. Now the unit for electric field strength is therefore Newton per coulomb. There is another category of electric fields which I want to discuss with you, but before I go there, I want you to understand something. That if you're at point A, we call this point A, versus you being at point B, versus you being at point, let's say, B and C have the same distance from the center, okay? So you have 3 points, A, B, and C. Question: is the force acting at point A and the force acting at point B the same? The answer is no. Force at A is not equal to the force at B. Where do you think is the force larger? So remember, the closer the two charges are, the closer you are to the source, utni strong repulsion hogi. Jitna dur jaoge, utni weak repulsion hogi. The weakening can also be identified by this separation between the electric field lines, which you can see is clearly increasing. So force A is not equal to force B. In fact, force A is greater than force B. Okay? And force B is equal to force C. Why? Because they have the same distance from the center of this charge, the source. Source वो है जिसका field होता है, ठीक है? So FA is greater than FB, FB is equal to FC. इसी तरह अगर मैं A, B और यहाँ पे D ले लूँ तो force at A will be greater than the force at B, force at B will be greater than the force at D. that tells you that the force keeps on changing. Such a field in which the force keeps on changing is called a non-uniform field. Alright? एक ऐसा फील्ड जिसमें हर पॉइंट पे डिस्टेंस चेंज करने से फोर्स चेंज हो रही है, उसको हम बोलते हैं नॉन यूनिफॉर्म फील्ड. So I was telling you that there's another category. The other category is that of a uniform field. Let me scroll this up so we can focus on uniform fields now. Talking of uniform fields meaning, the word uniform meaning constant, so a constant force which will not depend on distance. So you have two plates, you have a positive plate and a negative plate. First of all, their electric field. So electric field will be pointing from positive to negative. The field lines will be equally spaced, and remember that at the edges the field curves like that. And now, how did you create this electric field? Basically, you took the two plates, you connected them with a battery, and there you had an electric field. Now let's say I take 3 points, point A, point B, and point C, and I put the same charge at the 3 points, and the charge is positive. And the question is, how does the force of, now you know positive and positive repel, so the force is going to be downward, right? The question is, how would the force at A and the force at B and the force at C compare? Your answer would be that the force at A would be equal to the force at B, would be equal to the force at C. The reason is, this is a uniform field. Acha. Now, the potential difference or the battery's EMF is V. The distance between these two plates is D. So the electric field strength is V upon D. Electric field strength is V upon D, where V is the potential difference between the plates and D is the separation between the plates. Do not forget this. So electric field strength का एक और यूनिट भी निकल आता है, which is volt per meter. Nonetheless, if you are at point A and this is the charge, which is positive. So if you ask me कि क्या इधर electric field strength is equals to force over charge valid होगा? बिल्कुल, ये तो defining equation है, ये तो change हो ही नहीं सकती. जितनी force लग रही है इसके ऊपर downward, वो force ऊपर रखो, charge नीचे रखो. कौन सा charge? ये वाला charge. तो इलेक्ट्रिक फील्ड स्ट्रेंथ निकल आएगी. सिर्फ यूनिफॉर्म फील्ड्स में एक और इक्वेशन आ जाती है, विच इज इलेक्ट्रिक फील्ड स्ट्रेंथ इज इक्वल्स टू V over D, or sometimes you even write it as delta V over delta D, because it's the potential difference and the difference between the two plates, the distance. Both mean the same thing. Alright, so in a note I can tell you that the force per unit charge must be equal to delta V over delta D. Very important equation, because at times you can be asked to use this equation to find out what the force is. You will have the potential difference, you will have the charge, and you will have the distance between the plates. Alright, remember, this is the distance between the plates. This distance is not the distance of the charge from the top plate or the charge from the bottom plate. This is the distance between the plates. Remember, जब भी confusion हो कहाँ से ये क्या कौन सा distance है, तो वापस जाया करो to the source. ये आया D कहाँ से आ रहा है? यहाँ से आ रहा है, यहाँ से आ रहा है. What is D? Separation between the plates. D is not the distance from the top plate or the bottom plate. It's the distance between the plates. Now, you can understand very important relationships here. If you increase the potential difference, which means you use a stronger battery, the force increases. So force is proportional to the potential difference between the plates. Naturally, अगर आप stronger battery लगाएंगे तो इन charges को ज़्यादा force feel होगी. The force is proportional to the charge that you have put. Now you've placed a small charge, it experiences a force proportionally. आप ये चार्ज बड़ा करोगे तो रिपल्शन ज़्यादा होगी, फोर्स बढ़ेगी. आप ये चार्ज 4 टाइम्स ज़्यादा करोगे, वो रिपल्शन 4 टाइम्स. डिस्टेंस वही रखो और चार्ज बढ़ाते जाओ. And what about D? D is the separation between the plates. If you bring the two plates closer to each other, like this, if you bring the plates closer to each other, and you have connected them to the same battery like before, now tell me, have you concentrated the field in a smaller space? Yes or no? Of course you have. So the field lines will become closer and the field gets stronger because it's more dense now. The field lines are closer. So the force inversely relates with distance, which means if you decrease the distance between the plates, उसी point A पे force ज़्यादा feel होगी because the field strong हो गया. Alright, so again a very very important concept that you understand the three relationships of V, Q and D, and then obviously you must also understand one particular graph of interest to me, which is if you have these two plates and you have connected them with a cell, okay, let's say this is a 10 volt cell and the separation between them is D, right? Let's say this is distance D1. I am going to measure distance D1 from here. So this is a point charge, this guy distance D1. और हम एक ग्राफ बनाने लगे of V versus D1, how the voltage varies with the distance. Now at the top plate, the voltage would be 10 volts. At the bottom plate, it'll be 0 volts, right? So when you come down to this point, what will the voltage be? It will be 10? No, it will be 9. You come down further, utni equal distance hai, 8, 7, 6, 5, 4, 3, 2 and 1, and then you will come to 0. So my point being that the values will continue to decrease in a very orderly manner. The potential will decrease in a uniform manner as this distance increases. Therefore, if I ask you to plot a graph of how the voltage varies with this distance D1, D1 बढ़ रहा है, ऊपर top plate से ले रहे हो, D1 बढ़ रहा है. You will say when D1 was 0, which means you were at the top plate, the voltage was very high. And as you came down, the voltage decreased uniformly. Linear relationship. But negative, not an inverse relationship, it's a linear negative relationship because the values are not decreasing exponentially, they're decreasing linearly, okay? So straight line down like that. And if I ask you, what does the gradient of this line give? So the gradient of this line would be V over D or delta V over delta D, which is the electric field strength. Now, obviously, the gradient would turn out to be negative, but you know what? Why is it negative? It's negative because the potential is decreasing as D is increasing, but the gradient's magnitude would represent the magnitude of the electric field. So there are two categories of questions in which you can be judged on your understanding. One is that if, let's say, you have an alpha particle or a beta particle. Now you know alpha particles are positively charged, beta particles are negatively charged. I'm talking of beta negative, not beta positive. If alpha particles are positively charged, let's say the upper plate is positive and the lower plate is negative, for example. So they have connected a battery. Where will the alpha particles go? The alpha particles would go down, definitely. Why? Because opposites attract. Where would the beta negative particles go? The beta negative particles would go up, obviously. Now, why are the two paths different? The answer is very simple. The answer to that is that alpha particles are more massive. Hence, they take longer in turning as compared to beta negative particles. Then, another question that can be asked is that these paths, they do not follow the arc of a circle. They do not follow the arc of a circle. Why? The reason is that the force does not always act perpendicularly to the direction of motion. So आपको ये पता है ना कि सर्कल बनाने के लिए, if let's say you have to draw a circle, then to make a circle something needs to go like this, and the force always has to be in this direction. The force and the velocity must always have a 90-degree angle between them. If they don't, it won't form a circle. So over here, it's that is what's happening. So at this point, yes, your velocity is this way. Let me draw it. At this point, your velocity is this way, and the force is this way. But then your velocity is this way, the force is still vertically upward. So now the angle is not 90. Initially it was. So the force does not always act perpendicularly to the direction of motion, which is why it does not follow the arc of a circle. If the force always acted perpendicular to the direction of motion, it would have been the arc of a circle. That's one category of questions. Then they can give you a numerical on the same concept. Now, how can they give you a numerical on the same concept? They can say that they had a positively charged particle moving it in this direction with a speed vh. For example, I'm saying vh because it's horizontal, as you can completely see. Let's say the upper plate is positive and the lower plate is negative. And let's assume that they have also provided you with the voltage across the two plates. So you know the voltage across the two plates, you know the distance between the two plates, that's given by L, you know the length of the plate, that is D. Their question now is that you have to numerically prove whether this charged particle, when it comes, will it hit the plate, yes or no? That's the question. Okay? देखो ये हो सकता था ना, ये पॉजिटिव चार्ज नीचे की तरफ बेंड करके यहाँ से बाहर निकल जाता. ये भी हो सकता था कि नीचे बेंड करके इसको हिट कर जाए. That's the question. Will the charge particle hit the plate, yes or no? All they've given you is what I'm telling you, the voltage, the distance between the two plates, the length of a plate, and this horizontal velocity, V. Now, you should know that when this charge particle comes in at this point, let me do it in green, the only force acting on it is this force, right? So the acceleration is going to be in this direction. Let me call that as vertical acceleration. There is no acceleration in this direction. Try to understand. So the horizontal acceleration is 0 meters per second square, whether they say in the question or not. Because the acceleration is only going to be vertical, and that is also because there's this electric field. अगर electric field ना होता तो ये vertical acceleration ना होती. अगर gravitational field होता तो 9.81 होती. But यहाँ पर हम gravitational effects को ignore करते हैं. याद रखें, electric force is way stronger than the gravitational force. Remember this. So they can always ask you, okay, why have you ignored gravitational effects? You can say that the electric force is very strong as compared to the gravitational force. Well, now, so this charged particle was coming in, it's going to turn downward. Why? Because there's a force acting this way, there's a vertical acceleration, not 9.81, because this force is electric force, not the gravitational force. And there's no horizontal acceleration. Why? Because there's no force pushing it in this direction. A constant speed से चलता हुआ आ रहा है, वो speed vh है. इसके steps क्या होंगे? Steps लिखने से पहले, remember the question, does the particle hit the plate? Does the particle hit the lower plate? That is what we're trying to find. So step number one. Step number one would be you find out what time it took between the plates. So how long was it for between the plates? Now, how long was it for between the plates? What do you have? You have this speed. Question. Speed is distance over time. I have the horizontal acceleration, I have the horizontal velocity. What equation should I use? I should use v is equal to u plus at. vh, ah. Now horizontal acceleration is 0, so that goes away. So vh is equals to uh, so that I cannot use that. Then s equals to ut plus 1 half at square. I could use that equation. I have the horizontal distance, I have the horizontal velocity, I need to find the time, and horizontal acceleration is 0, so this part gets cancelled. So I'm going to use this equation. sh is equals to uh into t. Remember one thing, whenever your speed is constant, please do not forget this, whenever your speed is constant, you can directly use the formula speed is equal to distance over time. Only then. यहाँ पे देख लें, ये डिस्टेंस है, ये टाइम है, ये स्पीड है, तो स्पीड इज इक्वल्स टू डिस्टेंस, और ये टाइम स्पीड इज डिस्टेंस ओवर टाइम. So speed vh dh. Now you have vh and you have dh. Dh is d in the question, as you can see. So d upon vh will give you the time. This is the time between the plates. That's stage 1 or step 1. Now you have the time between the plates. उतने ही टाइम में आपने हॉरिजॉन्टली मूव करना है और उसी टाइम में आपने नीचे भी जाना है. ये बात ज़हन में बिठाएं. ये आपने जो टाइम निकाला है, दिस टाइम, प्लीज़ नेवर एवर से TH. टाइम इज स्केलर, डज नॉट हैव डायरेक्शन. सो टाइम टेकन to go in this direction is the same as the time taken to go vertically down. So you've basically found out the time between the plates in which it's going to move down. Now, step number 2. Step number 2 would be to find out what the vertical acceleration was. Now, to find out what the vertical acceleration was, there are multiple ways to go about it, but you can use F is equals to ma to find out what it was. To find F, you could use V into Q over D is equals to M into AV. As I told you, V is the potential difference between the plates given. This D is this length L, so I'll rub it and I will write L over here. Q is the charge. The charge will be given. The charge you will put over here. The mass will also be given. You'll put over there and you will end up getting the vertical acceleration. So the vertical acceleration, let me write that down. This is the acceleration. So the vertical acceleration would be VQ over M into L. And you get the vertical acceleration from here. Now, once you have the vertical acceleration, step number 3. Step number 3 would be to find out how much distance did you travel. Let me call this distance as S. How much distance S did you travel? Vertically. SV. SV. Vertical. Now, you use the equation S is equals to ut plus 1 half at square. Ask yourself, what all do you have? SV, UV, AV. What was your initial vertical speed? You had a lot of horizontal speed, but you did not have any vertical speed. Now, they won't tell you, but you're supposed to know. So the initial vertical speed is 0. The initial vertical speed is 0 because the particle was moving horizontally. So there is no vertical speed initially. ये तो plates के दरमियान में आने के बाद आई है. So initially there was no vertical speed. SV निकालना है. AV हमने यहाँ से निकाल लिया. T हमने यहाँ से निकाल लिया था. So हम निकाल लेंगे यहाँ पे SV. So SV would be equal to 1 half of AV into T square. And the final step, step number 4. Once you get to this value of SV, you will compare SV with L divided by 2. Why L divided by 2? Because SV is this distance. L is the total distance. Now this distance is going to be L divided by 2. This particle was midway between the plates initially. So SV is going to be equal to, if SV will be compared with L divided by 2. मुझे बताएं, if SV, the vertical distance traveled by the particle, and L by 2 become equal, what does that mean? Did it hit the plate, yes or no? If SV, the vertical distance traveled by the particle, and L by 2, they become equal, what does that mean? Did it hit the plate? Yes, it did hit the plate. So if your particle hit the plate, then SV would be greater than or equal to L divided by 2. देखें, अगर SV L by 2 से ज़्यादा होगा तो उसका ही मतलब यही है कि हिट कर गया. अब क्वेश्चन वाले को तो नहीं पता ना कि यहाँ पे कुछ जो क्वेश्चन सॉल्व कर रहा है उसको क्या फ़र्क पड़ता है कि वो डिस्टेंस SV जो है वो L by 2 आता है, L by 2 से ज़्यादा आता है. L by 2 से ज़्यादा आता है तो L by 2 तो क्रॉस करना पड़ेगा ना उसको. L by 2 से ज़्यादा भी होने के लिए इतना डिस्टेंस मूव करके ही ज़्यादा डिस्टेंस ट्रैवल करेगा ना. सो इफ़ SV इज़ ग्रेटर देन और इक्वल टू L by 2, दैट मीन्स इट हिट द प्लेट. And if it did not hit the plate, if it didn't hit the plate, then what do you think? SV, your vertical distance, would be less than L by 2. Because अब सोचो L by 2 तो ये distance है. If SV, this vertical distance, is less than L by 2, that means your particle came in and this is less than L by 2, this is less than L by 2, this is also less than L by 2. So it did not hit the plate. So if it didn't hit the plate, SV would be less than L by 2. But if it did hit the plate, then SV would be greater than or equal to L divided by 2. And that brings us to the end of electric fields AS.